Hello everyone. Previously we had discussed on the context management and the with statement, right? So today we'll be discussing on the functional programming. So let's get into the definition part first. So what does the functional programming do here? Functional programming is a programming paradigm where functions are treated as first class citizens, right? So where functions are treated as first class citizens and operations avoid mutable state and side effects right? So one more thing, Python supports functional programming through features like map, filter, reduce, and lambda functions. Again, Python supports functional programming through features like map, filter, reduce, and lambda functions. Just keep this in mind. Again, functional programming is a programming paradigm where functions are treated as first class citizens and operations avoid mutable state and side effects, right? So Python supports functional programming through features like map, filter, reduce, and lambda functions. We will be making use of this one in the example, so just keep this in mind: map, filter, reduce, and lambda functions. So before getting into the example part, so let's discuss some of the important points here. So we can pass the functions as arguments. So we have seen this one already, right? So we can just pass the functions as arguments as well. So we can pass the functions as arguments, return them from another function, return them from other functions, and store them in the variables as well, and functional programming uses pure functions, no side effects. So immutability and higher order functions. Here functional programming uses pure functions, immutability, and higher order functions. Just keep this in mind. This part is very important. Line number 6, right? So functional programming uses pure functions, immutability, and higher order functions. So core tools here is, as I have said, this keyword map, filter, reduce, and lambda function. So here map, filter, reduce from func tools and lambda. This is from the function tools, func tools and lambda, right? So this is it for the functional programming definition part and some important points. So now let's get into the example part. So I'll just go with a very simple example. So as I've said, we will be making use of map, filter, reduce from the func tools, right? So I'll just copy this one, func tools. So this one will be from func tools. Let's import reduce. Right, so let's go with a pure function to square a number. So mm, we'll be going with a pure function just to square a number. So I'll just go with def here, square. Let me pass the parameter x here. This is fine. Let me return we are squaring a number, right? So this will be x into x, x. This is fine. So next, let's go with nums equals 1 comma 2 comma 3 comma 4 comma 5. So this is fine. So this is fine, man. So let's make use of the map to apply square to each number. Let's make use of the map just to apply square to each number, right? So I'll just go with a squared here. This one equals list of, let's make use of the map here, map keyword. So this will be square. This is fine. Square comma we have made use of the nums keyword, right? So nums, which consists of the array basically, nums. This is fine. Map applies square to all the numbers. Here what is map doing? Map is applying square to all the numbers, right? So this is fine. Next, let's go with one more thing. Let's go with the filter. We are done with the map. Let's go with the filter. We have to go with the map, filter, and reduce, right? So let's go with the filter now, just to keep the even numbers. Filter, what it does, basically we have to go with certain conditions, right? When we are making use of the filter, let's make use of the filter just to keep the even numbers. So I'll just go with the evens here. This one is fine. List, this is also fine. I'll just go with the filter. This is also fine. Let me go with lambda, x. This is fine. X module 2. This is equal to 0 comma nums. So this is fine. Filter keeps x if x module 2 is 0, right? So this is also fine, I believe. And next, let's make use of the reduce to sum all the numbers, right? So let's make use of the reduce. to sum all the numbers. Finally, I'll just go with the total keyword here. So this is equal to reduce lambda. So this is fine. This will be a comma b, a plus b nums. So this is also fine, man. So we are just reducing, we are just making use of the reduce that applies lambda cumulatively, right? So we are done with the map, uh, filter as well as the reduce, right? So we are done with the map, filter and reduce. Now let's print something just for the interactiveness. So I'll just go with the print. So let me go with squared here, squared. So this will be, let me pass the squared variable. So this is fine. Next, let me print here e1, right? So e1, or let me go with the e1s here. So let me pass e1s. This is also fine. The final one is here total sum. So I'll just go with the print. So this is fine. Total sum. This is fine. Total. So this is it, one. This is it for the code. This is it for the code. So the output that we need to get here is squared. So the square of each number. For the squared, we have to get the square of each number, means 2, 4, 9, 16 and 25, right? So this has to be 1, right? So square of 1, sorry, 1, 4, 9, 16 and 25. So for the e1s, we have to get this one, 2 and 4. We are just extracting the e1s, right? So that is the reason we are making use of the filter here. So 2 and 4 are the even numbers that we have to get as output, right? So reduce, we are just reducing to the single number here. So we are just going with the total basically. We are just making, yeah, we are reducing to the symbol number. We have to get the total of all the numbers. So when we sum up all the numbers here, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. 15 is the output that we need to get here, right? So let's see. Let's run the code here. Let's run the code. I hope this works, man. Let's see. Let me copy the file name. Let me paste it over here. Dot py. Dot py. So yeah, here squared we are getting 149, 16, 25. Square this one. Square of each number, right? So 1, 2, 3, 4, 5. We are getting the correct output. Evens, we are getting the correct even numbers that is present in the nums array, right? So finally, the total sum. The total, when we sum up all the numbers, we have to get the output 15. Yeah, we are getting the 15, which is absolutely correct. We are getting the desired output, right? So here map square of square comma nums whatever I have written. So basically this applies square to each item, right? So 1, 4, 9, 16 and 25. So that's what it does. And filter here, filter of lambda whatever I have written here. So this returns only even numbers, and reduce whatever I have made use of here. This combines all the values into the single result, nothing but the sum here in this case, right? So that is the reason we are getting the output 15 at the end. So 1, 4, 9, 16, 25, 2, 4, 15. We are getting the desired output, right? So this is it for the functional programming. This is it for the functional programming. So let me summarize whatever we have learned so far. So functional programming, what it does, it emphasizes immutability, pure functions and statelessness. Functional programming emphasizes immutability, pure functions and statelessness. So we make use of map, filter and reduce for clean, concise processing. For clean, concise processing. Python supports functional patterns even though it's not a purely functional language. Python supports functional patterns even though it's not a purely functional language, right? So this is it for the functional programming. So this is it for the functional programming, right? So now we are done with the functional programming, but next we'll be discussing about the meta classes and type magic, right? So next we'll be discussing on the topic meta classes and type magic. For now, this is it. Thanks for watching, guys.